Okay. In series combination, if you want to find the equivalent capacitance, then you have this formula. And I have told you, when two capacitors are connected in series, you should learn this. We will use these in the numericals, and we have calculated all the related things, and we have done one question also. And today we will discuss about the parallel combination of capacitor. And I think this chapter will be finished today. Parallel combination of capacitors. We will see how the capacitors are connected in parallel. Parallel combination looks like this. You can connect n number of capacitors, but just for the understanding, I am connecting only 3 capacitors. Okay, you can connect n number of capacitor like this, like this. You can increase the number of capacitors. So I am just connecting the 4 capacitors only, and from here a battery is connected like this. Okay. This battery has a potential difference or voltage of V. This is C1, this is C2, this is C3, and this is C4. In parallel combination, the voltage or the potential difference across each capacitor is same, and that is equal to V. From here you can see that. So I have told you how to check whether the potential or whether the voltage will decrease. Move from here. This is the positive terminal of the white battery. This is the negative terminal of the battery. Now you are moving like this, like this. There is no capacitor resistor. 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 So I am supposing this as terminal A. This point is A and this point is B. Now you can see from here you are moving, moving and moving and moving and moving and moving. Here is also the potential will be VA. Here will be the potential VA, and there is no capacitor or resistor. So till here also the potential is VA. Now VA, you are moving from here to here, and now you are moving in this here to the capacitor C2. No capacitance or resistance means here is also VA. In the same way, you can say here is also VA. In the same way, you can say here is also VA. And if you are moving in this direction, there is no capacitor resistor. Here is the potential V. Here also the potential will be V. Here also the potential will be V. Here also the potential will only drop when in the path there will be either resistance or capacitance or bulb. Okay, there are if in the path there are devices that consumes the voltage, that consumes the potential, like capacitors can consume the voltage, like resistor can consume the voltage, then only the potential will decrease. Otherwise otherwise it will remain same. So I can say V1 is equal to VA minus VB. Voltage across, this is V1 is voltage across C1. V1 is VA minus VB. For V2, voltage across C2, I can write VA minus VB, and you can write it for V3 also, VA minus VB. You can write it for V4 also. Okay. If you are connecting n number of capacitor, the potential difference will always remain same. Potential difference will always remain same. But I have told you, if Q charge is flowing from here, Q is the total charge from this, Q is the charge is flowing from here, here, here. And I have told you, due to the branching of wire, the charge will divide. So if here is a charge Q, here is no branching, no branching, no branching. Now here there are, from here there are 4 branches. So charge here is Q1, here is charge Q2, here is charge Q3, and here is charge Q4. Here is charge Q3, here is charge Q4. And when you move along this path, the charge will remain same. Here is also Q1. So here is also charge will, means in this wire, the charge will same. Here is also charge Q2 because there is no branching. Here is also charge, sorry, not Q2, Q1. This is Q1. This is Q1. This is, here is charge Q2. Here is also charge Q3. Here is Q4. Here is charge Q4. Okay. Here is charge Q4. Here the charge is divided. Why? Because due to these branches. So if I want to, I have already told you, I can write Q is equal to, Q is dividing like this. So I can write Q1 plus Q2 plus Q3 plus Q4, and you can write it for n number of capacitors. I am just writing for 4 capacitors. And if there are n number of capacitors, then you can write Qn. Okay. This is the equation 1. If instead of this circuit, instead of this, I will take a capacitance whose capacitance is equivalent to these all capacitors. See here. Now I have taken a voltage was V, and this is C equivalent. This C equivalent is this whole combination C1, C2, C3. This whole combination is C equivalent I have taken. And here is also charge Q. Here is also charge Q. So for this, I can write, if I want to calculate Q, so I can write Q is equal to CV, means C equivalent into potential difference. Q is equal to CV. Okay. And from here you can see, if you want to find Q1, Here, if you want to find Q1, so you will write C1 V1 and V1 is V. I am supposing V1 as V. VA minus VB is equal to V. I am supposing this is V. Supposing, not supposing, because this is equal to V. VA minus VB is equal to V. Okay. Here C1 V1. If you want to calculate Q2, then it will become C2 and V2 and so on. Qn is equal to Cn into Vn, and V1 equal to V2 is equal to V3. V1 is equal to V2 is equal to V3 is equal to Vn is equal to V. So for this I can write Q is equal to C1 V1 plus C2 V2 plus C3 V3 plus Cn Vn. Here V1 V2 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 V3 is V. I can write C1 V, C2 V, C3 V plus Cn V. This is Q. This is equal. I am taking common V. This will become C1 plus C2 plus C3 plus Cn. I can write this. And instead of this Q, I can write this. Instead of this Q, I can write C equivalent into V. C equivalent into V, and this will become V C1 plus C2 plus C3 plus and so on plus Cn. Okay. So this V and V will get cancel out. So C equivalent capacitance will be C1 plus C2 plus C3 plus Cn. This is the equivalent capacitance in parallel combination. Means add the capacitance simply. Okay. Okay. Potential is same, is equal to V. So please note it down. Nawal, have you got my point?
Yes, sir.
Actually, why the potential is same here? Why the potential is same? Because when you are moving from here to here, there is no capacitance or resistance. In the potential, if the potential at this point is VA, then here also the potential VA. Okay, here also the potential VA. We have discussed this earlier, no?
Yes, sir.
Okay, that's fine. So please note it down. This is the last lecture of this chapter, I think. After that, we will start current electricity.
Sir, can you scroll? Done, sir. Sir, you're muted. No, sir, your mic is mute.
Sorry. Actually, I was saying, have you completed this?
Yes, sir.
Okay, fine. So if I want to calculate the total voltage in the circuit, okay, I represent total voltage with V suffix T. Total voltage is equal to V simply, and total charge is Q, and Q can be written as C equivalent into V. C equivalent into V. Third is, if I want to calculate charge stored in each capacitor, means Q1. Q1 is equal to C1 into V, because potential difference is same. Q2 is equal to C2 into V, and you can calculate like this. Or if there are n capacitors, Cn into V. Voltage across each capacitor. Nawal, can you tell me what is the value of voltage across each capacitor? Nawal, what is the voltage across each capacitor?
Q by C1.
Array voltage across each capacitor voltage is same na, V1, V2, V3 is equal to V. What are you doing here? This is the parallel combination I have told you. I am telling this. V1 is the voltage across capacitor C1, and this is equal to V. VA minus VV is equal to V. V2 is V, V3 is V, V4 is V. Got now got my point?
Yes, sir.
What are you thinking? If I want to calculate energy stored in each capacitor, energy stored in each capacitor. Energy stored in capacitor 1 is equal to half C1 into V1 square, and this will equal to half C1 into V square, because V1 is equal to V. For U2, half C2 V2 square, so I can write half C2 into V square. In this way, you can calculate the energy. For nth capacitor, C3 into V3 square, you can write half C3 into V square. Okay. If you want to calculate the total energy, so you can write U1 plus U2 plus and so on UN. And this total energy can be written in one more form, half C equivalent into V square. Okay. Please note it down. Namal, from where you are?
I'm from Hyderabad.
You are from Hyderabad. Do you know Hindi?
Yes, sir.
Okay.
Secondary school. Secondary school.
UT is the total energy stored in capacitor. Have you completed this chapter in your school?
Yes, sir.
Then also you are doing like this.
Done, sir.
Okay. Do you want to get good marks in examination, or just you want to pass the examination?
I want to get good.
What?
Get good.
Your voice is not clear.
I want to get good marks.
Good marks means from the 100, it should be 99.9 or 100. These are good marks. Okay. And for that, you have to work hard. Okay, fine. If you will follow all the things properly, then maybe examiner can give you 101 marks out of 100. Okay. But if you do the things in a proper manner, if I am the examiner, I will give 101 out of 100. If I will see the student is excellent. Okay. So next question is, two capacitors are like this and connected with a battery of 10 volts. This is microfarad and this is 10. 1 microfarad equal to, Nawal?
10 to the power minus 7.
Very good. So we have to calculate number 1. C equivalent, number 2, total charge. Actually, I am not teaching like you are in CBSE or you are preparing for JEE Advanced or you are preparing for NEET. Okay. I am just teaching like you can solve any type of question, means with the help of these concepts. Okay. Total voltage. I am telling each and everything in a detailed manner. 4th is the charge stored in each capacitor. Nawal, what is your favorite subject? Which is your favorite subject?
Biology.
Very good. Energy is stored in each capacitor. Do you know this name? Organic chemistry.
Yes, sir.
There was a time when I was preparing for the JEE, okay, and I was in Kota. Have you heard about Kota, Rajasthan?
Yes, sir.
Very good. Okay, no problem. So I was preparing for the examination, and I this organic chemistry is one of the boring topic or subject for me. Okay, but I got highest marks in this. This was my scoring subject, but this was not my favorite subject. Okay, so we have to find the C equivalent. So C equivalent is simply calculate if I am supposing this as C1, this as C2. Okay, these are two capacitors connected in parallel combination. Why parallel combination? Because from here you can see, actually you should remember the network types. If this type of network, then you can say this combination is parallel combination of capacitor. And from here, if you want to go with concept, so you can see if here is potential V, then you are moving like this. Here is potential V, V, V. Here is same. Here is also V. Accordingly, you can check. Okay. So answer is C equivalent. If you want to calculate, then C1 plus C2. What is C1 plus C2? 10, 5 plus 10. 15 microfarad. Okay, first. If I want to calculate total charge is Q. We have represented total charge with Q, and Q is equal to C equivalent into the potential difference, and this is same for all. C equivalent is 15, and we will convert this into SI unit. 15 into 15 microfarad. This will be 15 into 10 to the power minus 6, and V is given or not 10. V is given as 10. This is V. V is given as 10 volts. So this is 10. So the answer is 150 into 10 to the power minus 6 coulomb. Okay. This is the total charge. Now, third part is total voltage. Total voltage is 10 volt. V total is equal to V, and that is equal to 10 volts. If someone is asking Nawal, what is the voltage across this 10 microfarad capacitor, what will be your answer?
The same.
Very good. Very good. Same. So, fourth point. Charge in the capacitor. Charge stored in capacitor. In each capacitor, you should write. In each capacitor means if the charge is Q is going from here, means from here the charge is Q. But from this point, the charge will divide. Here the charge will, you can say this will be Q2 and this will be Q1. So if you want to calculate the charge across each capacitor, means Q1 is equal to C1 into V1. What is the value of C1? 5 microfarad. 5 into 10 to the power minus 6. And V1 is equal to V. V1 is equal to V. V1 is equal to V. That is 10 volts. This is 10 volts. This will become cooler. So want to calculate Q2, then C2 into V2. C2 is equal to 10 into 10 to the minus 6 into 10. This will become 100 into 10 to the power minus 6. And if you want to calculate the total charge, so you will simply add them, or you can calculate the total charge from C equivalent into V. The answer will remain C. And energy stored in each capacitor means energy stored in capacitor 1 is equal to half C1 into V1 square. This will half. Value of C1 is equal to 5 into 10 to the power minus 6, and value of V1 is 10 square, and the answer will be 250 is the 250 na? Into 10 to the minus 6 minus 6 joule. The unit of SI unit of energy is joule. For U2, half C2 V2 square, half, this will 10 minus 6, 10 square, this will become 500 into 10 to the power minus 6 joule. Okay, please note it down. Very, very easy question this is.
So you can
Comple-
see. Done, sir. Done, sir.
Okay. Actually, I have stopped due to Azan. Okay. So have you understood how to solve?
Yes, sir.
Okay, we will solve some questions. These are the question of CBSE, I think. Okay, let's start. See here, three capacitors, 1 microfarad, 2 microfarad, and 3 microfarads are joined in series like this. This is the series combination. And how many times will the capacity become when they are joined in parallel? Okay, this is 1 microfarad, this is 2 microfarad, and this is 3 microfarad. They are connected in series. Firstly, they are connected in series. This is 1 microfarad, 2 microfarad, and this is 3 microfarad. Okay. And for the series combination, if I want to calculate the equivalent, CS is the equivalent capacitance in series. What is the formula, Nawal? For the series combination?
1 by C1 plus 1 by C1.
Okay, good. 1 by C1 plus. So this will become 1 by 2, 1 by 1 plus 1 by 2 plus 1 by 3. This will become okay, we will solve this. The LCM is 6. So here you can write 6, or this will become 2. This will become 11 by 6. And if you will calculate C as this will become 6 by 11 microfarad. In series combination, the okay, when they are connected in series. Now, if I am connecting these in parallel, if I have connected these capacitor in parallel, means I have connected these like this. Okay, and this is connected with some battery. This is not the capacitor, this is battery. And having same battery, and this is 1 microfarad, this is 2 microfarad, and this is 3 microfarad. This is microfarad, this is microfarad. Calculate this equivalent. C equivalent is simply 1 plus 2 plus 3. This will become equal to 6. And they are asking how many times the capacity will become. How many times means I am writing C equivalent as CP. Equivalent capacitance is that CP divided by, divide CP with CS. CP is 6, CS is 6 by 11, and this 11 will come here. 6 and 6 gone. This will become 11. So when you will connect, this will become 11 times. The capacity will become 11 times. Means the capacitance will become 11 times. This is first question. This is first question. Now another question. See this question. They are saying that two capacitors of 6 microfarad and 12 microfarad are connected in series. So connect them in series. This is what is this? This is 6 microfarad. 6 microfarad. This is 12 microfarad. This is micro. This is looking like R, but this is micro. Connected in series with a battery. Connected with a battery. No problem. The voltage across 6 microfarad. Voltage across this voltage is unknown. But we know the voltage across this. Means if I am supposing this is C1, this is C2. So V1 is given to us. V1 is given to us 2 volts. V1 is given to us as 2 volts. So simple. Calculate the equivalent capacitance first. This is series combination. So I have told you how to calculate C1 C2 divided by C1 plus C2. So this will become 6 into 12 divided by 6 plus 12. This will become 6 into 12. This will become 18. Gone. 3. 3 fours are. So answer is 4 microfarad. Means equivalent capacitance is 4 microfarad, and suppose charge is flowing Q. Q charge is flowing. Here also the charge will Q, and here also the charge will Q, because the series combination. Calculate Q. Q is equal to C equivalent into total voltage of battery. We know this. We don't know this, but we know this. Q is equal to C1 into V1. Charge in capacitance 1. Charge in capacitance 1. This is Q1. Q1 is equal to Q. Q1 is equal to Q. You can write from here. Q1 is equal to Q, and C1 is equal to 6 microfarad. 6 microfarad. And V1, we know the V1, 2 volt. So Q will become 12 into 10 to the power minus 6 coulomb. So now we have Q. Can we calculate this V from this? Q is 12 into 10 to the power minus 6. C equivalent is 4 microfarad. And V we have to calculate. See here, they are saying calculate or compute the total battery voltage. Okay. So please tell me the answer of voltage. What is the answer of V? What will be V? Nawal? Are you listening?
Yes, sir. Sorry, my mic wasn't working.
Okay, no problem. So please tell me what will be the value of V here?
3.
Very good. 3 volts. This is our answer. Okay, now we have this question. See, these kinds of questions will come in the examination. Very, very, very easy. Okay. So this is the question now. First, read the question. Find the ratio of potential difference that must be applied across the parallel and series combination of two capacitors C1 and C2 with their capacitance in the ratio 1:3, so that the energy stored in the two cases becomes same. Very good. They are saying first arrange the capacitors in series, okay, and calculate the energy, and after that connect those C1 and C2 in parallel and calculate the energy and equate the energy and find the what we have to find ratio of potential difference. Very simple. So firstly I am connecting the capacitor with some potential difference, means voltage V1. Here is C1 and C2. In this question, we have just ratio of C1 and C2 is equal to 3. Sorry, 1:3. This will 1 divided by 3. So from here I can calculate C2 is equal to 3 times of C1. So now calculate here the equivalent capacitance. This is series combination. So I am calculating C12. C12 is C equivalent. What is the formula? C1 C2 divided by C1 plus C2. C1 is C1 and I am putting the value of C2. C2 is 3 times of C1. C1 is C1. C2 is 3 times of C1. This will become 3 C1 square. Okay. And this will become 4 times of C1. Now this will become 3 by 4 of C1. C equivalent means in series C12. Okay, in series. So instead of C12, you should write CS. It will look better. CS means equivalent capacitance in the series combination. CS. Okay, CS is equal to this. Now they are saying connect these capacitor in parallel. They are saying connect these capacitor in parallel. This is C1, this is C2, and now this time V2. Why I am taking V2 here? See here, find the ratio of potential difference that must be applied across the parallel and series combination. Okay, parallel and series combination. Okay, do one thing more. This is I am representing V1 with Vs because it will be easy for you. This is potential. We are applying the voltage Vs in series. Okay, and now here calculate the energy when applied. Sorry, in series. What is the formula of energy? Half C equivalent into V square. This is half. C equivalent is 3 divided by 4 into C1. V square is Vs square. So we have energy in series as half into 3 by 4 C1 into Ps square. Now in parallel. In parallel, C equivalent will be C1 plus C2, and we know C1 is C1 and C2 is 3 times of C1. See here, C2 is 3 times of C1. C2 is 3 times of C1, so this will become 4 times of C1. So if I want to calculate the energy in parallel, I will write half C equivalent into V. This is not V2, this is Vs, PP. Means applied voltage in parallel. This is VP. this is into Vp square. Half Cv square, we have formula of energy. Now they are saying equate both the energies. They are saying US is equal to UP. What is the value of US? US is half 3 by 4 C1, half 3 by 4 C1 into V S square, or UP is equal to U suffix P is equal to half into 4C1 into potential in parallel square. Now cancel out all the things. Nawal, can you tell me the ratio of voltages? We have to find the parallel. VPY, I need VPY VS. Please tell me answer. Okay, please calculate it. What is the answer?
1 second, sir.
Okay, 1 second. Fine.
Root 34 by 4.
Okay, you can check. This is the answer.
Yes, sir.
Very good. Means you are a good student. Okay, we got this. Okay, now we have one last topic. And after that, this chapter will be finished. At the CBSE level. So, um, this is the last topic, and this is the last topic. This is the star. So if the capacitor, we know the plates of capacitors are represented as in the front view like this and like this. We represent like you can I have told you many times, these are the plates. This is one plate, this is another plate. If I am putting the plates like this, you will see only two parallel lines. If I am putting this, you will only see these two parallel lines. Okay, so this is the relation. So here one plate is positive charge, we know. This is the capacitor, one plate is positive charge, another in this is the parallel plate capacitor. Two plates separated by some distance, and the distance between these two plates is, suppose, d. Okay, this distance is d, and a is the area of each plate. A is the area of each plate. Means all the plates have, all not two, these two plates have equal area, like this have equal area. Okay, now what I have done, okay, for the distance of means in half of the area, this is the whole area of the plate, this is the whole area of the capacitor, this is the whole area of capacitor, this and this and this and this and this. Okay, this is the whole area of the capacitor. Okay, in half of the area I have filled a dielectric, I have filled a dielectric, I have filled a dielectric. See here, these are the plates. Okay, these are the plates. Okay, and this is the total area, this is the total area, and in the half of the area, means from here to here, this is the capacitor. Okay, this is the capacitor, right? And this is the area of the plate, this is the area of the plate, and the in the half of the area, in the half of the area means here to here, like this. Okay, like this, in this area. Okay, we are, this area is filling with dielectric. In this area A by 2, we are filling dielectric constant, dielectric with constant K1, and in this area we are filling dielectric, another dielectric with some constant K2. Okay, this is the dielectric, and in this area A by 2, this area is divided into half, and we are filling it with K2. Okay, so now see here, if now this will become a capacitor. this will become one capacitor, this will become another type of capacitor, another capacitor. Okay, now these are not the same capacitance, capacitor with capacitance. So if I want to calculate the capacitance of this, I am supposing this as C1, this as C2. Means here is capacitance C1 in AY2 area, capacitor of capacitance C2. If I want to calculate C1, then we have the formula K epsilon naught AYD. K is here K1 epsilon naught area AY2, and distance D will remain same, and distance D will remain same. So it will become 2D epsilon naught A by 2D, and this will become K1 epsilon naught A divided by 2D. Similarly, I can find C2, K2 epsilon naught A by 2D. So this will become K2 epsilon naught A by 2D. And now how we will decide whether these are connected in parallel or in connected in series? Okay, so there is a way. This is one capacitor and this is another capacitor. Means positive of capacitor is connected with positive and negative of capacitor is connected with negative. Let's see here. This is positive, we know, and this will be negative, and this is positive and this is negative, like this, no? So series combination is the connection of plates with connection of opposite plate. But in case of parallel plate, what we do, we connect the plates like this. Okay, this is positive, this is positive, this is negative, this is negative. Means we connect the positive plate with positive plate, and we connect the negative plate with negative plate. You can see here. You can see here. So here positive plate is connected with positive plates, means this combination is parallel combination. This combination is parallel combination, means here positive plate is connected with positive plate. So for positive combination, if I want to calculate C equivalent, this will become C1 plus C2, and what is C1? K1 epsilon naught A by 2D plus K2 epsilon naught A by 2D, and you will get the answer C equivalent as epsilon naught A by 2D K1 plus K2. Okay. And write here one thing more. If area divides, it implies that parallel combination of capacitors. Okay. So this is series. Why this is series? Because this is positive, this is negative. This is positive, this is negative. So if this is positive, then this is positive. If this is negative, then this. And we know that two plates are oppositely charged. So this is positive, this will be negative. So this is series. This is parallel. So please write down this. If area divides, then the combination is parallel combination. Please write this also. This is very important for solving this. And please remember this, these are the dielectrics. Dielectric. This is also dielectric.
Second school.
If area divides, then you can understand that the capacitors are connected in parallel combination. So this is the formula. C equivalent for parallel when dielectric is filled between the area.
Done, sir.
Okay. These are two plates again, and this is positively charged plate. This is again a parallel plate capacitor. This is negative. And this time what I am doing, I am filling the dielectric like this. I am filling the dielectric like here to here. Okay. Like this, I have filled dielectric. Means in a distance, this is the distance dy 2. This whole distance is d. Now I am filling dielectric in a distance dy 2. And another dielectric. Here is another dielectric in another distance. This is dielectric, okay? And I am filling this dielectric. In distance d by 2, another dielectric is filled. Now how we will decide this will be in parallel, or we know this will be in series if this is in parallel, so I will talk about series, but how? See here is a positive charge. Okay, here is a positive charge, and due to the dielectric, on the dielectric there will be a, you can say simply here a negative charge is induced. Here a negative charge will be induced. And here a positive charge will be induced. So at this time, now this time, this is series combination because positive negative plate is connected to positive plates. See here, in series combination, negative plate is connected to positive plates, or you can say positive plate is, means opposite plates are connected. Here also now opposite plates are connected. So this is the series combination. So for this, if I want to calculate the C1, here in the distance D2, this is one capacitor having the capacitance C1, this is C2, and in this I am filling the dielectric with constant K1. I am filling this dielectric with constant K1 and this with K2. Okay, if I want to calculate C1, then we have the formula for C1. If I want to calculate C1, K epsilon for C1, okay, for C1, as area is not changing here now. Area is not changing of the plate. Area same for this capacitor, and area is same for this capacitor also. Okay, so C1 is K1 epsilon naught, area is not changing, but distance is changing. Distance will become d by 2. So I can write this will become 2K1 epsilon naught A divided by D. Similarly, if you will calculate C2, this will become K2 epsilon naught A divided by D2 d by 2. This will become 2K2 epsilon naught A divided by D. And in this combination, if I want to calculate the, okay, if I want to calculate the equivalent capacitance, then we know that the formula C1 C2 C1 plus C2 C1 C2 C1 plus C2. Okay, so like this also, but I am calculating this with some different way. I am calculating this like this: C equivalent is equal to 1 upon C1 plus 1 upon C2. So 1 upon C equivalent is equal to 1 upon C1, means this will become, this C1 will become 1 upon C1. If you will to reverse of this, this will become D upon 2K1 epsilon naught. D upon 2K1 epsilon naught A, and this will become D upon 2K2 epsilon naught A. Now take common. What is common here? D is common, 2 common, epsilon naught A common. D upon 2 epsilon naught A is common. Is common, and what is here? Here is 1 by K1, 1 by K2. Okay. And if you want to find C equivalent, this will become D 2 epsilon naught A. This will become K1 plus K2 divided by K1 K2, and C equivalent will be 2 epsilon naught A divided by T. This will become K1 K2 divided by K1 plus K2. This is the final formula. Okay, please note it down. And after that, we will solve one numerical, and then this chapter is over and this class is also over. Now we will start after this chapter. Very easy chapter, current electricity.
Second school. Second school.
This is C equivalent when connected in series. And
Also.
okay, very good. Now we have a numerical on this. So the numerical is this. The question is this. Here you can see in this question, this is the question and I am writing the answer directly. So here you are seeing that this is the case of series or parallel. This is the case of series because here the one, please write one more thing there. Write one more thing there. Here you can write if separation D divides then capacitors are in series. If area divides parallel, if distance divides series. If separation, write this down. If separation D divides, then capacitors are in series. So here the separation divides. Separation is divided. So this capacitor, these capacitors are connected in series combination, and this is the parallel combination. And for series combination, we have equivalent capacitance. For the series combination, we have epsilon naught A, area is not changing here, divided by 2D K1 plus K2. K1 plus, no, sorry, yaar. This is not for series, this is for parallel. For series, we have this formula. Equivalent for series, this is in series, na? So this have 2 epsilon naught A divided by D K1 plus, sorry, K1 K2 K1 K2 divided by K1 plus K2 K1 K2 divided by K1 plus K2. This is CS, and if I want to calculate equivalent capacitance in parallel, then what will be the formula? Epsilon naught A, we have derived this formula, epsilon naught A divided by 2D K1 plus K2. Okay, and they are asking find the ratio of capacitance. Find the ratio of capacitance is 2 in 2 arrangement. Means we have to find Cp divided by Cs. We have to find Cp divided by Cs. Cp is epsilon naught A divided by 2D K1 plus K2. This will become 2 epsilon naught A divided by D K1 K2 K1 plus K2. This will become K1 K2 K1 plus K2. Now epsilon naught A D, okay, and this will become, and this will also we cancel out. No, not cancel out, means you can write here Cp divided by Cs as we have now K1 plus K2 divided by 2, and in denominator we have 2 K1 K2 divided by K1 plus K2. So for this expression I can write K1 plus K2 divided by 2, and this K1 plus K2 divided by 2 K1 K2 K2. So the answer is ratio Cp by Cs is the K1 plus K2 square divided by 4 times of K1. So please note it down. Here the dielectric is filled with, and that divides the distance. So this is series combination. This is parallel combination. Why? Because here area is divided. Means the dielectric is divided into the area. Are you writing, Nawal?
Yes, sir.
Okay, please write. And this is the end of this chapter.
Second school. Second school.
Okay. So Nawal, that's all for today, and we have completed one chapter also. So and please revise your notes. Okay, and if you have any doubt, any types of problem in the questions or in the concepts, you can ask me. Okay, and try to revise the notes, okay, as much
Sir.
as possible. Okay, because these things are very useful for you, and all the questions will be asked like this. Means this question was the toughest, I think. This question was the toughest. You can see the toughest question. Mm, You should you should always try to remember the formulas and concept, and try to practice, okay, on your copy. Okay, that is my advice for you. And okay, now you can leave. Thank you.